Hello, it's Professor Asma Parveen from Department of Psychology, Aligarh Muslim University. Today I will be talking about probability or random sampling in quantitative research. In quantitative research, there are various methods for selecting samples. These methods can be categorized into three main groups: random sampling designs, non random sampling designs, and mixed sampling designs. Random or probability sampling designs involve selecting participants in a way that gives each individual an equal chance of being chosen. This method ensures that the sample is representative of the larger population. Examples of random sampling designs include simple random sampling, stratified sampling, and cluster sampling. Non random or non probability sampling designs, on the other hand, do not provide every individual in the population with an equal chance of being selected. Instead, participants are chosen based on specific criteria or convenience. This method may be used when it is difficult to assess certain This method may be used when it is difficult to access certain individuals or when time and resources are limited. Non random probability sampling designs include purposive sampling, snowball, quota, accidental, and convenience and expert sampling. There are also mixed sampling design which combines elements of both random and non random probability. There is also mixed sampling design which combines elements of both random and non random sampling designs. This approach allows researchers to take advantage of the strength of each method while minimizing their limitations. For example, a researcher may use random sampling to select a representative sample from a larger population and then use non random sampling to gather additional data from specific subgroups within that sample. Overall, the choice of sampling design in quantitative research depends on various factors such as the questions of the research, available resources, and the desired level of desired level of generalizability. Each method has its own advantages and disadvantages, and researchers must carefully consider these factors when selecting a sampling design for their study. By understanding the different options available, researchers can ensure that their sample accurately represents the population they are studying and that their findings can be confidently applied to the larger population. The first category of sampling design is probability or random sampling designs. These designs are crucial in research because they ensure fairness and accuracy in selecting participants for a study. Every element in the population being studied has an equal and independent chance of being selected for the sample. Equality means that each element has the same probability of being chosen, regardless of personal preferences or other factors. Independence means that the choice of one element does not depend on the choice of another. To illustrate this concept, let's imagine a class with 100 students, but 20 of them refuse to participate in a study. In order to include all 100 students, a sample of only 80 can be used. However, excluding these 20 students means that each student does not have an equal chance of being selected, resulting in an inaccurate representation of the entire class. This same principle applies to communities as well. Alongside refusal to participate, there may be challenges in identifying all the residents within a community. If a significant number of people cannot be included in the sample due to identification difficulties or refusal, There, then the sample will not provide an equal chance of selection for each element in the population. Consequently, the sample will fail to accurately represent the total community. So, when we are doing a research, it is important to ensure that the sample chosen should be representative of the entire population. This means that each individual in the population has an equal chance of being selected. However, there are situations where the idea of independent selection cannot be compromised. For example, if a group of friends is being sampled and one person refuses to participate because their friends were not chosen, then the sample is no longer independent. The selection of one person is dependent on the selection of others, which does not accurately represent the whole population. This concept can also be applied to a larger community. If a small group within the community decides that either all of them will participate or none of them will, then the sample is again not independent. In these cases, the inclusion or exclusion of a specific group within the population affects the selection process. As a result, the sample may not accurately reflect the characteristics of the entire population. However, it is important to consider that if only a few individuals refuse to participate, it should not greatly impact the representativeness of the sample. In practical terms, there will always be some people who do not want to take part in a study. It is only when the number of refusals become significantly large that it becomes a concern. In such cases, the sample may no longer be representative of the population as a whole. Random or probability samples have two main advantages. These samples are crucial in research studies to ensure accurate and unbiased results, and failure to do so introduce bias into the study and compromising the validity. Random samples offer two significant advantages. Firstly, the conclusions drawn from these samples can be generalized to the entire population under investigation. This allows researchers to make broader claims and predictions based on their findings. Secondly, certain statistical tests that rely on probability theory can only be used with data collected from random samples. These tests play a crucial role in establishing definite connections between variables, allowing researchers to make meaningful and reliable conclusions about the relationships within the population. When it comes to select a random sample, there are three common methods that can be used, and these are considered as methods of selecting a random sample. The first method that is used by researchers to select a random sample is fishbowl draw. This method is useful for small populations because in this method each element in the population is assigned a number and written on separate strips of paper. These strips are then placed into a bowl, and without looking you randomly select strips until you have chosen the desired number of elements for your sample. It is similar to how some lotteries are conducted. The second method involves using a computer program specifically designed for selecting random samples. These programs generate random samples and ensure a fair and unbiased selection process. They can be helpful when dealing with larger populations or when more precise randomness is required. Third method that is used by researchers for selection of a random sample is a table of randomly generated numbers. Many research methodology and statistics books include these tables in their appendixes. These tables provide a list of pre generated random numbers that can be utilized for selecting a random sample. So, by utilizing these three methods, you can ensure that your sample is truly random and representative of the larger population. It's important to remember that the goal of selecting a random sample is to minimize bias and to obtain accurate results. So, whether you choose fishbowl draw, a computer program, or a table of randomly generated numbers, the key is to prioritize randomness in your sampling process. Sampling is a method that is used to gather data, and it can be done in two different ways, with replacement or without replacement. When sampling without replacement, each selection affects the probability of the next selection. For example, if you want to choose 20 students out of a total of 100, the probability of selecting the first student is 1 by 100. However, as each student is selected, there are fewer options left, so the probability changes for each subsequent selection. By the time you choose the 20th student, the probability of their selection is 1 by 81. This type of sampling does not follow the idea of randomization, where each element should have an equal and independent chance of being chosen. On the other hand, sampling with replacement involves putting the selected element back into the sampling population. This means that it could be chosen again in future selections. However, if the sampling population is large enough, the chances of selecting the same element twice are quite low. Sampling with replacement allows for each element to have an equal and independent chance of being selected in every selection, which aligns more closely with the concept of randomization. The choice between sampling with or without replacement depends on the specific objectives of the study. If the objective is to accurately represent the population and maintain the independence of each selection, then sampling without replacement would be the appropriate choice. However, if the objective is to simply gather data and the independence of each selection is not crucial, then sampling with replacement can be a more efficient method. Now, I will talk about random sampling techniques. Random sampling is a very important tool in every research, and there are three main types of random sampling designs that researchers are commonly using. Simple random sampling ensures unbiased selection of individuals from a population. Stratified random sampling divides the population into groups and selects individuals from each group, providing a representative sample. Third category is the cluster sampling, which involves selecting clusters from the population and including all individuals within those clusters in the sample. Each of these three methods have their own advantages, and it is used depending on the specific research objectives and constraints. So the first method is simple random sampling. Choosing a sample from a population can be done in various ways, but the simplest method is called simple random sampling. This approach ensures that each person or thing in the population has an equal chance of being selected. In theory, this technique can be used for populations of any size. However, in practice, it can be challenging to implement. One common method of random sampling is called random sampling without replacement, where you select someone or something from the population and then remove them. Another method is random sampling with replacement, where the selected individual or item is put back into the population, giving them another chance of being chosen. In a simple random sample, every member of the population has an equal opportunity to be selected. It is important to include everyone in the population when conducting this type of sampling. To achieve this, researchers can utilize tools such as random number generators or other methods that rely entirely on chance. These techniques help ensure fairness and reduce bias in the selection process. So, in order to select a random sample, various tools and methods can be utilized. One such method is the use of random number generators or other chance based techniques. For example, imagine you are tasked with selecting a simple random sample of 1,000 employees from a social media marketing company. To accomplish this, Each employee in the company database is assigned a unique number ranging from 1 to 1000. Subsequently, a random number generator is employed to choose 100 numbers from this range. This process ensures that the sample is representative of the entire employee population. By using random sampling, researchers can obtain a representative sample that accurately reflects the characteristics of the population. And this is crucial for drawing valid conclusions and making generalizations about the entire population based on the sample data. This simple random sampling process has certain steps. And the first step is to define the population, which means identifying the specific population that the researchers want to learn. It's important to ensure that this population accurately represents the outcome the researchers are trying to understand. The second step is to choose the sample size. Researchers need to decide how many people from the overall population they will select. It is crucial to select a sample size that is large enough to truly represent the entire population. This ensures that the findings from the sample can be generalized to the larger population. Third step is to determine population units. This involves creating a comprehensive list of all the individuals within the population being studied. By compiling this information, researchers can ensure that their findings are representative of the whole population, not just a select few. This step is crucial in providing accurate data for further analysis. Once you have your population, the next step is to assign each person a random number. This number does not have any significance, it is just a way to identify them. For example, the first person on the list could be given the number 1 and the last person could be given the number 5000 if the population is consisted of 5000 people. After assigning numbers, it is a time to choose a random sample from the population. It is the time to choose a random sample from the population. From the list of 5000 people with their assigned numbers, you will randomly select 500 individuals to be part of your sample group. This ensures that your sample is representative of the larger population and reduces bias. Once you have your random sample, you can begin your study. By selecting a random sample, you increase the likelihood that your findings will be applicable to the entire population. This is important because it allows you to make generalizations and draw conclusions about the whole population based on the sample. Random sampling is a crucial technique in research as it helps to minimize bias and increase the validity of the results. It ensures that every individual in the population has an equal chance of being selected for the study. This way, your sample is more likely to accurately represent the characteristics and diversity of the population you are studying. Simple random sampling is a method that allows researchers to select a sample from a larger population in a completely random and unbiased manner. This technique has numerous advantages, making it a popular choice among researchers. And the first advantage of simple random sampling is that it is easy to implement and does not require extensive resources or complex procedures. Random sampling involves selecting group of individuals from the entire population in a way ensures that each person has an equal chance of being chosen. Unlike other sampling methods that require dividing the population into smaller groups, random sampling simplifies the process by directly selecting individuals without any additional steps. Researchers can easily reach out to the selected participants and gather the necessary information without having to go through complicated procedures. This saves time and resources, making the research more efficient and feasible. Another important advantage of simple random sampling suggests that by choosing a random sample, researchers believe that this subset of people will accurately represent the entire population. This eliminates the need for further segmentation and requirement and refinement of the group. This method eliminates the need for researchers to make subjective decisions about who should be included in this study. It removes any potential bias that could arise from handpicking participants based on personal preferences or preconceived notions. Random sampling allows for a more objective and fair selection process. Simple random sampling allows for statistical analysis. This is the next advantage of simple random sampling because the random nature of the sample allows researchers to use various statistical tests to analyze the data and draw meaningful conclusions. By using statistical techniques, researchers can identify relationships within the data, providing valuable inputs into the research question. Another advantage of random sampling is that it is inexpensive because it can save money and produce unbiased results. Instead of dividing people into smaller groups, sampling allows to use an existing population, this eliminating the need for costly surveys. This approach ensures fairness in the sample, minimizing the influence of the researchers. So, by utilizing this method, researchers obtain data without compromising the integrity of their study. Another advantage of simple random sampling is that it minimizes bias. Since each individual in the population has an equal chance of being selected, there is no favoritism or prejudice involved in the selection process. This reduces the potential for biased results and ensures that the sample is truly representative of the population. Simple random sampling ensures that the sample is representative of the population, which increases the generalizability of the findings. This means that the results obtained from the sample can be confidently applied to the larger population, and this is the another advantage of simple random sampling. Additionally, this method also provides a high level of precision and accuracy as the randomness of the selection process reduces the likelihood of systematic errors. Overall, we can say that simple random sampling is a very important tool for researchers as it allows them to obtain reliable and generalizable results. Using a simple random sampling can have its own drawbacks also, and one of the limitation is that it may not accurately represent the entire population. This means that certain groups of people could be left out of the sample, leading to incomplete population demographics. For example, if we randomly select 25 people from a population of 100, it is possible that all 25 could be men and no women. This lack of diversity in the sample could affect the results by not including a female perspective. Sampling errors are another issue that can arise and is considered as one of the limitation of simple random sampling method. These sampling errors occur when the sample does not accurately reflect the population due to chance. So, even if we do include a diverse group of individuals in our sample, there is still a possibility that the sample may not accurately represent the population as a whole. Random sampling method also has certain limitations, and one major limitation arises when the population being studied is either infinite or very large. In these cases, it is simply not feasible to list every single unit in the population. Additionally, even if it is possible, the cost of doing so can be prohibitively expensive. Another limitation arises when the population is diverse. It means when population contains a wide range of characteristics. In such cases, the random sample chosen may not accurately represent all the unique qualities and attributes present in the entire population. These limitations highlight the need for alternative methods of data collection that can address these challenges and provide a more comprehensive understanding of the population as a whole. This is all for today. Thank you.